So in this video, we are looking at future value tables. As you can see when we were doing the recurrence relation in the previous video, it ended up being really tedious calculating future values there. There was a lot of writing into the recurrence relation, resubstituting, getting a value out, putting it back in, and it took a really, really long time. Now, future value tables are useful because someone has gone ahead and factored in all of these calculations and has expressed it on a table for us to find a future value for some given conditions, okay? So now future value tables basically show the future value of an annuity when $1 is invested at the end of the period at the given interest rate for the given number of periods. Now these two things, the interest rate and the number of periods, are our conditions that change, right? Because we can have different interest rates, different number of time periods that we have this investment going for. Now, in order to use a future value table, we have to determine the time period and rate of interest. That will be in the question. Then on the table, there will be an intersection point. This is written in rows and columns. We will see on the table the intersection of the time period we're looking at and the rate of interest. Once we find this on the table, we just multiply the number in the intersection with the money contributed because it's the value of an annuity for every $1 invested. Now, I've written this in the form of a formula down here to make it easier to think of. To find the future value, we take the intersection value and multiply it by the payment, okay? So in example 1, we have this future value table. So immediately, it's easier to work with than a recurrence relation because we just have to find our value on the actual table. So what we're going to do, looking at this table, it's saying that we are using the above table to calculate the future value of $34,000 per year for 3 years at 5% per annum, compounded annually, okay? So what we're gonna do is we're gonna look on the table and we're gonna line up 3 years with 5%. So if you look, these two intersect over here. So what we're gonna do, our intersection value is 3.1525. So to find our future value, we multiply our intersection by the payment. So the payment here is $34,000. So this tells you, because remember, the key thing here is future value of $1. So for every $1 we invest at these conditions here, we will get $3.1525. So for 34,000, we have to multiply those two. So when we multiply them, that's going to give us 107,185. So the future value is this amount here. Now, part B, that's saying we're trying to find it for the condition of 5,000 per half year for 2 years at 6% compounded 6 monthly. So it's compounding 2 times a year, right? It's compounding every 6 months. So anytime the compounding period changes, that's going to change both our number of compounding periods as well as the interest rate. So the number of compounding periods, instead of compounding once a year, it compounds twice a year. So for 2 years, it's going to compound 2 times every year. So that's going to give you 4. And the interest rate is going to change from 6% to 3%. So we have 0.06 divided by 2 gives you 0.03 or 3%. Okay, now, once we've done that, we can calculate the intersection on our table. So let's just rub this one out so it avoids confusion. We have 4, we're looking at the period of 4 intersecting with 3%. So this is our value here. So your intersection is 4.1836. So your future value is going to be your intersection 4.1836 multiplied by 5,000. That's the amount we are investing. So that gives us a future value of 20,918. So this is like an easier, hopefully to understand, initial example of using this table of future values. We are finding the intersection point. To find the future value, we multiply that by our payment. Now, in example 2, some of these questions will get a little bit trickier, but we're still just getting used to working with the table. Now, for the first one, it's saying, what is the future value of an investment of $300 per month for 3 months at 24% per annum, compounded monthly? Now, it's for 3 months. So our payment period, N equals to 3. And our rate, because it's 24%, but it's compounded monthly, okay? So we have to divide 24% by 12. That gives us 2%. Now we have to find 3 with 2%. So these two are going to intersect here. So we have a future value equaling your intersection 3.060 multiplied by 300, because 300 is your payment that you're making. So once we do that, it's going to give us a future value of $918. Okay, next one. It's saying, what is the future value of an investment of $15,000 per quarter for 1 year at 12% per annum compounded quarterly? Okay, so this is where the wording gets a little bit tricky, okay? So we have our payment per quarter for 1 year at 12% per annum compounded quarterly. So we need to find out our N and our R before we do anything. Now, if we think of our N, it's compounded per quarter, so 4 times in a year for 1 year. So our N is going to be 4 times 1, which equals 4. And our rate, we have to take 12% per annum and divide it by 4 because it's compounded quarterly. So R equals 12% divided by 4, which gives you 3%. Now, looking at the table, we have N equals 4, R equals 3, period is 4, rate is 3%, so we have 4.184. So it's still asking for the future value, so I can write FV equals to 4.184 multiplied by 15,000. And that gives, once you put it in your calculator, 62,760. Okay, now part C and part D are different, okay? If you read the question, here it's asking us to find the payment or contribution per period. So we're not finding the future value. We've been given a future value and we've been given the rate and the number of years. So we still have to find the intersection, but when we do this, we're going to find the payment in a slightly different way. Now, part C, I'm going to find everything I need. We've been given a future value, 76,713. We need to find our intersection. So I have 3.5% per annum compounded annually for 4 years. So 4 years, 3.5%. So 4.215 is the intersection value. So 4.215 Now, remember, I wrote that formula on the previous page. The future value equals the intersection times the payment. I'll just write that as PMT. Now, if I substitute into this formula, 76,713 is the future value. The intersection is 4.215. And the payment I want to find. This is just a one-step equation. I can divide both sides by 4.215 to find the payment. So PMT equals 76,713 divided by 4.215. Once I do that, the payment is going to be 18,200. So I'm doing the question in the exact same way. I'm just substituting into the formula and it'll just require an extra step because I'm not looking for the future value. I'm not multiplying, I'm dividing instead once I go through all the steps. Now part D, very last one. It's saying once again to find the payment. So I'm just underlining all the key bits of information. For an annuity with a future value here, at 7% compounded biannually for 1 year. Biannually just means 2 times in 1 year. So we're going to write down everything we know. So we have our future value. Actually, I'll do that right at the end. Let's find the intersection. So here, the rate is going to be 7%. And it's compounded biannually. So we have 7% divided by 2, which gives us 3.5%. And our number is, it's compounding biannually for 1 year. So 2 times in 1 year. N is just going to be 2 times 1, which equals 2. So we find our intersection. 7% divided by 2 gives you 3.5. Our N is 2. So looking where N is 2 and 3.5, it's 2.035. That is our intersection. Now that we have that, we can just go straight into this. So the future value, let's write our formula again. Intersection multiplied by the payment. The future value is 6,105. The intersection was 2.035 multiplied by the payment. So the payment equals to 6,105 divided by 2.035. Once we do that, it will give you a payment of $3,000. So this is how we can use a future value table to find either a future value or find a payment for a whole bunch of different conditions. The wording will probably throw you off more than anything. We have to remember what it means to compound, say, biannually, and we have to be careful for the periods we are choosing as well as the rates, depending on what the question is telling us. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.